Now we're going to be learning the experimental prediction, okay? It's just very similar to what we've been doing. We're still going to use WKU. You need to be able to identify the fraction in the problem. So let's go ahead and see what that's going to look like. Example 1, it says, at Vanston, 7 out of 10 students who walked into the building had a sweater. Make sure you underline 7 out of 10 students because that's important information. It says, based on the information, if 100 students walked through the building, how many students could be expected to wear sweaters? Okay, so like I said, we are going to be using WKU. The question is asking us how many students are expected to be wearing sweaters, right? So we're looking for the probability of sweaters over total. The know part, that's what information that we know. We know that 7 out of 10 students had sweaters on. So we're going to write 7. And out of those 7, there's 10 students, right? Sorry, there's 10 students, and out of those 10, 7 were wearing sweaters. Now, it's asking us what would happen if 100 students walked through the building. So that means our second total is going to be 100. Now, we need to see, out of those 100, how many are wearing sweaters. So we're going to still solve it by using cross multiply and divide. Multiply these two and then divide by 10. Or you can find the relationship. Okay, I'm going to go ahead and solve it both ways for you. So 7 times 100 is going to give me 700, then divided by 10. 10 cannot go into 7, put a 0. 10 can go into 70 7 times, so subtract 70. It gives me 0, bring down 0, and 10 can't go into 0, so just throw it on top. So my answer is going to be 70. Now, if I were to find the relationship, I'm trying to see what number to multiply to get to 100. So 10 times 10 is going to give me 100. Whatever you do to the bottom, you have to do to the top. So 7 times 10 is 70. I still get the same answer. Okay, let's look at example 2. Example 2 says, in a recent study of 400 people revealed that 12 out of 20, underline important information, did not like the Dallas Cowboys. Based on the results of the study, how many people do like the Dallas Cowboys? So it's kind of giving us two different things. It's telling us how many people don't like the Cowboys, but the question wants to know how many like the Cowboys. So it's a little bit confusing. So let's carefully take all of our information that we know. We're going to set up WKU because it's still predicting. So WKU, it's asking how many like the Cowboys. So I'm going to put like CB for like the Cowboys. Okay, on the bottom is going to be your total. Now, 12 out of every 20 people did not like the Cowboys. So if I know 12 out of the 20 people, 12 out of 20 people don't like the Cowboys, then I can tell how many will like the Cowboys. It's the rest, right? So for my visual people, let's say that this is 12 people that don't like the Cowboys. Well, everything else is what they will like the Cowboys, right? All I have to do is subtract 20 minus 12, and what's left is 8. So 8 people like the Cowboys out of the 20, and my total is still going to be 20. Okay? Now, they're predicting what happens if 400 people. Okay? Out of 400 people, how many people like the Cowboys? So we set this up for cross multiply and divide. We're gonna cross multiply these two. So 8 times 400 0, 0. 8 times 4 is 32. Okay, now we're going to divide by 20. So 32, 0, 0 divided by 20. Now, this is a pretty big number. What you could do is cross off a 0 on the outside and on the inside. This is going to be a little bit easier, so now you're dividing 2 into 320. 2 goes into 3 one time, minus 2. Bring down the second 2. Now 2 goes into 12 6 times, so 2 times 6 is 12, 0. And 2 cannot go into 0, so we're just going to throw it up there. So now our answer is 160. 160 people like the Cowboys out of that 400. That's what that tells me. I want you to go ahead and skip this part, just put an X on the solve. I'm going to start this problem for you and you're going to finish. Okay? You're also going to do the check-in by yourself. Okay? Example 3 says, Mr. Dixon flipped 2 coins during a probability experiment. The outcomes of the first 30 trials are shown in the table. So it's telling me there's a total of 30 trials. So that's going to be our total. Based on the information in the table, how many of the next 120 will the outcome be for both coins showing head? So if I look over here, it tells you what the coins landed on, right? So my question is asking for both coins showing heads. So that's going to be 2 heads right here. So we're going to be looking at this in our table. So we are still predicting, so we're going to write WKU. The probability of landing on 2 heads, so I'm going to put 2H. On the bottom, I'm going to put total. Now the total for this chart, or this table, is going to be 30. And out of those 30, only 7. Both of the coins landed on heads. Okay. And now the trials, the predicting trials is going to be 120, so it's going to go right here. Okay, you're going to cross multiply and divide, or you can find the relationship. I'm going to find my relationship because it's a lot easier. I know what number can be multiplied by 30 to get 120. So I know that if I multiply 30 times 4, it's going to give me 120. So I'm going to do the same to the top. 7 times 4, that's going to give me 28. That's going to be my answer. Okay, now I want you to do B. It says, in how many of the next 90 trials will the outcome be 1 head and 1 tail? So you're going to be looking at this. Make sure you set up WKU. Okay, it's going to be probability of 1 heads and 1 tails over total. Go ahead and finish that for me. Okay, after you finish, you're going to do the check-in by yourself. You're going to raise your hand when you're done so I can come by and check.